the directory structure of a module, write basic resource definitions for a service, add functionalities to the module to work with multiple platforms, and introduce features such as inheritance and variables. Our objective here is to create a fully functional web server service. The steps to be completed are to install the web server package, configure the main config file as a static file, configure a virtual host file as a dynamic file or template, run the service, and enable it to start at boot time, and finally, restart the service if any of the configuration file changes. We'll first go through the directory structure of a module. The manifests directory contains Puppet program files with .pp extension, and the actual Puppet code and the logics reside in these files. The files directory contains files to be created on the agents using the file resource type, where the contents are static and will always remain the same as the source. The templates directory contains files to be created on the agents using the file resource type, where the contents are dynamic and will be different for different agent nodes. These files are called templates. The first thing to understand in a Puppet manifest is the class definition. The first file in the manifest directory is the init.pp file. If the web server module is called by Puppet, it is to be assumed that the modules /webserver/manifests/init.pp file is being checked. All the code in a manifest file are written inside a class block. For each resource type we configure, we have to define a resource definition. The format of the definition is shown here. The definition starts with the resource type and then a block enclosed in curly braces. The identifier of the resource type is the unique name given to the resource. The next thing we need to do is write the attributes specific to the type and their respective values. We will now follow this format and create the 4 resources of our web server service. The first resource that we define is the package resource, which asks Puppet to install the HTTPD package. This example assumes that we are using a CentOS agent. We will get into more diverse configurations in a short while. The next resource that we configure is the file resource, which asks Puppet to create the /etc/httpd/conf/httpd.conf file on the agent, taking the static file as source from the files directory. When we define the source of the file with a Puppet : it means that Puppet needs to look in the files directory of the module for the mentioned file. We have configured the next resource, which is also a file resource, but the source here is not a file. It is a template, which is a dynamic file. Instead of the source attribute, we have configured the content attribute here, which states that the source is a template and has to be searched in the templates directory of the module. An example of the template has been shown here. The template is always configured with a .erb extension. The value of the server name directive in the template is a fact, which is the FQDN fact here. When this template is applied on different servers, the server name directive will have a value equal to the fully qualified domain name of the agent node. The final resource that we have described here is the service resource. We have asked Puppet to make sure that the HTTPD service is running and it is enabled to start automatically at boot time. We have also specified that a restart action can be performed on the service, without which Puppet will do a stop and then start when a restart needs to be done on the service. We will now assemble all the resource definitions into one single file in the class definition and create our manifest file. To do this, we will create a new file called manifests init.pp, and then we will include the entire configuration that we had been doing till now. The definition includes all the 4 resources that we have configured, and the next thing we are going to do is we are going to run the Puppet agent on the CentOS node. So we are going to run the Puppet agent --test with the server name. What happens here is that Puppet agent has failed to apply the manifest successfully. The reason for this is that the sequence in which the resources are applied is not serial. What Puppet tries to do here is to start the service and create the file before the package is installed, leading to a failure. To fix this problem, we need to add a few attributes to the manifest file. What we need to do here is we need to go back to our manifest init.pp file, and we need to tell Puppet that the files require the package httpd before the file resources can be applied. We need to do the same for both the files, and we also need to tell the service definition that it requires both the files for it to be applied. So here what we have done is we have created few dependencies. The file definitions will not be applied unless the package definition has been applied, and the service definition will not be applied unless the file definitions have been applied. The next thing we are going to do is we're going to save this file, and we are going to run the Puppet agent again. And this time we see that all our changes have been applied. The HTTP process is running, and we will verify that our template has been applied successfully. And there we see the server name has the FQDN of the agent that we have run the Puppet agent on. The next thing we are going to do is add support for Ubuntu in this configuration. The Apache Webserver package name, directory structure, and file names are all different for CentOS and Ubuntu. For this task, we will introduce new features called inheritance and variables. Conditionals are used to make decisions based on the target system or multiple other scenarios. Variables can be configured by creating a variable starting with a dollar symbol and then assigning values to it. First, we'll create a new file called parameters.pp. To do this, we'll go to etc, Puppet Labs, code, environments, production, modules, web server, manifests, and then we'll create a file called parameters.pp. We will need to add conditionals to our Puppet code to make it available to different operating systems. We will introduce some good coding practices and keep our init.pp clean. Instead, we will add the conditionals to the new file called parameters.pp. The next thing we are going to do is add our code to the file. As we have created a new file in the Webserver module, we will address the class as Webserver parameters. Here we have added conditionals based on the OS family fact. We have introduced variables in this file called package name, config file, config source, and vhost file. Based on what the OS family is, we have set variable names and the values respective to the different operating systems. This file will now be inherited by the main class in the init.pp file. A concept we will introduce here is inheritance. Logics and manifests defined in other manifest files can be easily used in our main manifest file using inheritance. The variables defined in the other manifest file can be fetched and stored in local variables to be used in the present manifest. The inherits option is used to tell the manifest to inherit the contents of the sub-manifest file. We will now change the configuration in the init.pp file. The new configuration states that the Webserver class is now accepting parameters from the Webserver parameters class. We have saved the remote parameters in local variables inside the braces and mentioned that this class inherits the Webserver parameters class. Next, we have changed the identifier names of the resource definitions to generic names such as webserver-package, config-file, vhost-file, and webserver-service. Instead of getting the package, file, and service names from this identifier, Puppet will now get the names for the package and service from the newly introduced name attribute and the file names from the newly introduced path attribute. Instead of setting names for these attributes, we have mentioned the variable names where we had previously stored the parameters from the parameters class. The final additional option we have added in this configuration is to add a notify attribute in the file resource definitions. This attribute refers to the service resource as its value, and it means that whenever the file changes, they will ask the service to be restarted to read the new configurations. The same functionality can also be achieved by adding a subscribe attribute to the service definition and setting the toFile definition as its value. For this task, we'll go with the notify attribute. The next thing we are going to do is try our module on the agent nodes. The first node we will try on is the CentOS agent. And there we have it. We have a successful run of our Puppet module. We are going to do the same on the Ubuntu agent next. That's it. We have got a working module which is valid for both the operating systems. Next, we are going to do a small test and see if our Puppet agent pick up the change. We are going to change the templates file on our module and change the fact here from fqdn to hostname. What this is going to do is this is going to trigger a change on the Puppet agent and the Apache daemon should restart. We will now run the Puppet agent again and see the changes that are applied. And there we can see a change of the template file where the fqdn is replaced by the hostname, and then a restart of the web server service takes place. We are going to test this on the Ubuntu node, and there we have the same change. In the next video, we will learn about configuring a Puppet server for production. In this section, we learned about configuration management and Puppet's position in the ecosystem. We learned about Puppet components and terminologies. We explored and understood the Puppet run cycle in details. We then learned to install and run the Puppet components. Finally, we got an overview of the Puppet.